So this video is for Integrated 2. This is on the classwork 2-23 to 25 plus angle review. So in this section, what we're going to be learning about is something called a converse. So we learn about an if-then statement, which we call a conditional statement. So in a conditional statement, the if portion of the statement is called the hypothesis. And the then portion is called the conclusion. If you reverse the order of the hypothesis and conclusion, then you have created the converse of the statement. Write the converse of the conditional statement. If angles are vertical, then they are congruent. Okay, so our if part here, if angles are vertical, then they are congruent. So we're going to be flipping that around. So we're going to say if angles are congruent, then the angles are vertical. Now it's asking us, is the original statement true or false? The original statement, if angles are vertical, then the angles are congruent. So the original statement is true. Vertical angles are congruent. Then they ask, is the converse true? So if angles are congruent, does that mean that they have to be vertical? And that is false. Not all congruent angles are vertical angles. So sometimes we give what we call a counterexample, something that would prove something is not true. So an example of congruent angles, when we have the angles in an equilateral triangle, right? They are congruent. They're each 60 degrees. Let me make this a little bigger here. And maybe I'll just actually use the triangle symbol here. Okay. And you would have this one is 60 degrees, this one is 60 degrees, this one is 60 degrees. Those are congruent, but they are not vertical, right? So that would be like a counter example. On 2-24, if conditional statements, every conditional statement has a converse. Consider the arrow diagram for a familiar relationship below. Triangles are congruent leads to all pairs of corresponding sides are congruent. So this is really saying if triangles are congruent, then all pairs of corresponding sides are congruent. In mathematics, to say that a statement is true, it must always be true. That is, it must follow from a definition or a theorem. Is this arrow diagram true? And this would be yes. When triangles are congruent, all of their corresponding parts are congruent, which means all three pairs of corresponding sides and all three angles, corresponding angles. Now it says write the converse of this arrow diagram as an arrow diagram or as a conditional statement. Okay, so this time what we're going to do is we are going to start with this part. We're going to start with this part in front of my if, and then this part is going to be in my then. Okay, so for this, so if all pairs of corresponding sides are congruent, does that lead to the triangles being congruent? And in this case, the answer is yes. By side, side, side triangle congruency. If all three sides are congruent, then the triangles are congruent. So if all three sides are congruent, that led to the triangles being congruent. So this was a true statement. Okay, that's what side, side, side is. Now consider another statement below. Is this statement true? Triangles are congruent. Okay, triangles are congruent. Then all pairs of corresponding angles are congruent. So is this true? Yes. Again, if triangles are congruent, then all of their corresponding parts are congruent. And that means all three pairs of corresponding sides, which we're not caring about in this situation, we did in the first one, and all three pairs of corresponding angles. That's what we care about. Now they want us to write the converse of this. So in this case, what we're going to say is all pairs of corresponding angles are congruent leads to triangles congruent. So basically, if all three sides are congruent, are the triangles congruent? So does angle, angle, angle lead to congruent triangles? That's kind of what we want to know. And we learned that that is not true. So this is false. Angle, angle, angle leads to similar triangles, but not necessarily congruent triangles. Write the converse of the arrow diagram below. Is the converse true? Justify your answer. So a polygon is a rectangle. Then the area of the polygon is base times height. So if we're going the other direction, we're going to say the area of a polygon is base times height. Then the polygon is a rectangle. And we want to decide if this is true or false. So are there any polygons that have base times height for their area that are not rectangles? I can think of one. So this is going to be false. Area of a parallelogram is equal to base times height. So doesn't have to be a rectangle. On 2-25, for each of the following statements, we're going to rewrite it as a conditional statement or an arrow diagram and state whether it's true or false. Okay, so conditional statement or arrow diagram, true or false. Then we're also going to do the converse. Okay. So we need to either do if then, or we need to do arrow diagrams. Okay. So all squares are rhombuses. So if a polygon is a square, then it is a rhombus. Now, in this case, we need to decide, is that true? Are squares necessarily rhombuses? And the definition of a rhombus is that it is a polygon with all four sides being congruent. And that is also true of a square. So this is going to be true. Now we're going to do the converse. So if a polygon is a rhombus, then it is a square. So all squares are rhombuses. So that the first one I wrote was true. Are all rhombuses necessarily squares? This is going to be false. Not all rhombuses have 90-degree angles. Not all rhombuses have 90-degree angles like a square. They just have to have four equal sides. Okay, so the next one. Every isosceles triangle is equilateral. Okay, again, we're going to write this as an if then. So if a triangle is isosceles, then it is equilateral. So if a triangle is isosceles, then it is equilateral. And an isosceles triangle has two equal sides, where an equilateral has to have three equal sides. So just because a triangle has two equal sides does not mean or imply that it's going to have all three. So this is going to be false. Now, if I do the converse, if a triangle is equilateral, then it is isosceles. And an equilateral triangle has three equal sides. An isosceles has to have two equal sides. So this is actually going to be true because an equilateral has three sides and I only need two for it to be isosceles. two parallel lines cut by a transversal form same side interior angles that are supplementary. So if two parallel lines are cut by a transversal, then same side interior angles are supplementary. That is true. We learned about that. So that is true. Now, the converse, if same side interior angles are supplementary, then the two lines cut by a transversal must be parallel. Now, this one we haven't proven to be true or false yet. So this one you can take your best guess as to what you think the verdict will be. The real answer to this is that this is going to be true. Okay, we're going to actually prove this in class next time. So now the rest of this is review of angle relationships. Okay, review of angle relationships. So for each of these, we are going to be writing equations and working these out and justifying our answers. Okay, we're going to have a quiz this week on angles and triangle congruencies. And so we want to make sure that we understand all the terms for this. So on this first one, we have a right triangle. We have two angles, this 2x minus 9 and this 3x plus 4. And we know angles in a triangle add to 180, but since we already have 90 already used up, I know that my 2x minus 9 and my 3x plus 4 have to equal 90. They're going to be complementary. So then you're going to solve this. And when we solve this, we are going to end up with our answer as 19. And that will be our answer. We need to write equations for these and not just give answers. On the next one, we are dealing with parallel lines cut by a transversal and alternate interior angles are congruent. So 10x minus 11 is equal to 8x plus 3. We're going to solve that. And we get x equals 7. Again, alternate interior angles congruent. On the next problem, we have a linear pair, and these are going to add to 180. So I'm going to have a 5x plus 5 plus 110 is equal to 180. So I'm going to have 5x plus 5 is equal to, let's say, 70. Okay, we could have also written that if you wanted to right away. And so this is going to be 5x is equal to 65, and x is going to equal 13. and this is a linear pair. And that means that they're going to add to 180 degrees. On number 4, we have a y and x's here. So these two are going to be a linear pair. Okay, so the green part's going to be a linear pair. And so I'm going to write 4x minus 2 plus 6x minus 8 equals 180 degrees. And then when I solve this, I'm going to have 10x is equal to 190. So x is equal to 19. Now, I need to find y. Y is going to be the same as the 6x minus 18 because they're corresponding. So they're going to be corresponding. So if I go 6 times 19 minus 8, and I work that out, 6 times 19 minus 8, I end up with 106. So y is going to equal the same as that, which is 106 degrees. Okay, on the next one, this y is pretty easy here. That y is going to equal 90 degrees. Okay, it is a right angle. Now that means that this other side together is also going to be 90 degrees because 90 and 90, the linear pair has to be 180. So I'm going to take 3x minus 6, add it with x minus 4, and set that equal to 90 degrees. Those are going to be complementary angles. So I'm going to get 4x minus 10 is equal to 90. 4x is equal to 100. So x is going to be 25. Now, on this next part, they want us to solve for x, then list the side lengths in order from shortest to longest. And they said it's not drawn to scale. So I know that if I take all 3 angles in here, they have to add to 180 degrees. The reason because triangle angle sum theorem. That states that the angles in a triangle add to 180. So I'm going to have x plus 3 plus 2x plus 4 plus 4x minus 2 equal 180. And let's see if I add my x's, I'm going to get 7x. I have a 7 and a 2, so that's a plus 5. Is equal to 180. 7x is equal to 175. And when I take 175 divided by 7, I end up with x being 25. Okay, so I need to figure out the angle values then. So this first angle here, okay, this angle here that I'm going to do in orange, that is going to be 28 degrees, okay. This angle here that I'm going to do in, let's say, purple, that's going to be 4 times 25 minus 2, so that's 100 minus 2, so that's going to be 100 minus 2, which is going to be a 98. So that's going to be 98 degrees. Now, if I put in my 25 for this one, 2 times 25 plus 4, I'm going to get 50 plus 4, so I'm going to get 54. Now, hopefully when I add those up, all of those are going to add up to 180 degrees. Let's just double check it. So if I take 25 plus 98 plus 54, 25 plus 98, oh, so not 25, sorry, 28. 25 was my x. 28 is my orange there. Okay, so 28 plus 98 plus 54, I do get 180 degrees, so that did work out. Now, they want to know the side, we want to know which side lengths are shortest to longest. So the shortest angle is 28 degrees. So this side here that I'm doing in orange, which is going to be line segment AT, is going to be the shortest side because it's across from the shortest angle. Now, the largest angle is my purple angle, and across from that is going to be my longest side, which is going to be AC. And then my middle one is going to be across from my green one, which is going to be CT. Okay, and that is by the theorem that we listed where we're talking about the larger the side, the larger the angle, the longer the side. Okay, we have that in our theorems. On 7 for this, I'm going to use the triangle inequality property. And so what I'm going to do for each of these, I'm just going to choose, let's say this one, this one, this one, this one, the third one, and see if it is satisfied. So for the first one, I'm going to take my 4 and 3 and I'm going to subtract them and I'm going to add them. And this one has to be in between the two numbers I got, and it's not. Okay, it cannot equal 1, so this is not a triangle. On my next one, I'm going to do 5 minus 1 is 4. 5 plus 1 is 6. 5 plus 1 is 6. Okay. And then my 3, which is this one here, has to be in between those two numbers, 4 and 6. And it's not. So this is not a triangle. My next one, 8 minus 4 is 4. And if I add 8 and 4, I get 12. And so again, I'm trying to see if this 10 is going to be in between the 4 and the 12. And so, yes, triangle. And the last one, 4 minus 4 is 0. 4 plus 4 is 8. Is 5 in between 0 and 8? Yes. So it is a triangle. And again, the reason for this is the triangle inequality theorem.